All right, take a look at the question number 6. All right, just try to understand, okay, what the question is up there. Particle P moves along the x-axis such that for time t is positive, okay, greater than 0, its position is given by xp over here. This is the particle P position, P, with time t equals 6 minus 4 times e to the minus t. Okay. Another particle P, this is P. Another particle Q over here. At this time, it gives us only velocity. Okay, this is the velocity. Velocity Q times T equals 1 over T squared. So we have two particles. Okay, so one is given by the position, the other one is velocity. Okay, this velocity is given when t equals 0, the initial over here. Okay, when t equals to 1, its position is 2. Okay, that means what? Position, I'm going to use this one is, they use the k, okay, y, okay, position. This is use the x, the other one is y, okay. yq, when time t is 1, the particle is now at value of 2. Okay, yeah, that's the given. All right, from A, find velocity of a particle P, okay, the velocity of particle at time to t. That's the first one. We're going to find the velocity over here. Velocity particle P over here, okay? We're talking about this velocity particle P. Velocity particle P is what? A derivative of position function. That's right. Velocity particle T equals what? Derivative position function. Are you okay with this? So what is derivative of 6 minus 4 times e to the negative t? Derivative is what is there? Constant is 0. Negative t, that exponent is still negative t, but we multiply what? Derivative of negative t, right? That is a negative 1, isn't it? We still over here. Negative 4 to the e minus t. Same as this one, but we multiply derivative of negative t is negative 1, right? So it's going to be equals positive e to the negative t. That's the velocity of particle P. Up to here, so far, okay? All right. That's number A, okay? This is easy one, all right? Just take a derivative of position of particle P, okay? Second one there. AQT is the acceleration of particle Q at time t to 0, at time t, okay? Find all value of times. For t is positive, you're going to find that t is positive in these intervals. When the speed of particle Q is decreasing, so we're going to find the time t in this interval, the speed, the particle Q is decreasing. Speed is decreasing. For the particle Q, right? We're going to talking about only particle Q. Speed decreasing, we have the formula here. Velocity is positive, acceleration positive, that is speed is increasing, right? It's okay? Speed up. When they have the same sign. Velocity is negative, acceleration negative, opposite side. Still speed up, right? But over speed is decreasing is what? They are opposite sign. I'm going to use this way. different way. Okay, we don't have to write two equations. Just what velocity times acceleration is negative, right? One is positive, the other one is negative, or this is negative, the other one is positive, right? Opposite sign. Now the particle, the speed is what slowed down. So we're gonna find the interval of time. Its velocity is given by over here already. Velocity is 1 over t squared. Particle q velocity is already what? 1 over t squared. It is 1 over t squared. Okay, the next one is we need to find the acceleration. What is the acceleration? Derivative 1 over t squared again, right? Particle q acceleration is what? Derivative. I'm going to take this one as the exponent form, okay? 1 over t squared is t to the negative 2, right? We take a derivative. That is the accelerations. Can you find the derivative of this one? Negative 2 move to the front. Negative 2 t negative 2 minus 1 is negative 3, right? That is the derivative. So which one equals to what? Negative 2 over t cubed, isn't it? Are you okay with this?
Yeah.
Now check out their time. 1 over t squared is positive or negative? T is greater than 0 in this interval. T squared is always positive, right? This is always positive. 1 over divided by positive still always positive. Are you okay with this?
Yeah.
1 over t squared is always positive. First one.
Yeah.
What about acceleration? What about acceleration? AQT, particle QT. Acceleration is what? Negative 2 over t cubed. This one t cubed is a positive number, t cubed is still positive. So negative 2 divided by positive is still negative, right? So interval is what? For any time t is greater than 0, right? Always what? The speed is decreasing, right? That's the answer. Okay? Because we can say now velocity is positive and acceleration is negative. Okay, we can see it over here, right? We have to show it this way. Then you get the full credit. Okay? Anyway, this is the answer, okay? This is the reason why the speed is what? Decreasing. Is it okay? Alright, now C, take a look number C there. Find the YQT, that is the position of particle Q. We're gonna find it, okay? Position of the particle Q is only what velocity is given. So we need to take right integral, right? Because the initial condition is there. So 1 over t squared. The YQT position of particle Q is what is that? Integral 1 over t squared and dt, isn't it? Are you okay with this?
Yeah.
That's a velocity integral, right? So what is the antiderivative of this one? We can continue t to the negative 2 dt by the formula, right? You can add 1 there. Negative 2 plus 1 equals negative 1. So it's going to be t to the negative 1. But we need divided by same numbers, negative 1 again. That's right. So this one equals what? Negative 1 over t. Are you okay with this? But we need y constant, c, right? So position of particle q is negative 1 over t and plus c. But we're going to determine the value of c using initial conditions. Initial condition is, where is it? yq, when t is 1, y is 2, right? That is initial conditions. Put this number when t is 1 there, okay? So actually this one, final, okay? When t is 1, yq is 2, so 2 equals, put this number t is 1 there, negative 1 over 1 and plus c. This is negative 1, plus 1 plus 1 both sides, c equals to 3. The position of particle q equals how much? Negative 1 over t and plus 3. Okay? That is the answer, choice C. Is it okay?
Yeah.
All right. To this, you gotta do everything, okay? In case if you have a time, right? After you finish A and B, you can continue C and D, right? All right. Now the number D there. T goes to infinite in the long way, okay, of time t, which particle will eventually be parted from the origin. Okay, to find this position, so we need to find the right position functions. We already got the position function of particle Q already. Oh, particle P over here too. Okay, particle P is already there. Particle P position is 6 minus 4 e to the t is what? 4 over e to the t, right? Same thing. And the position particle Q position function equals what we already got over here. Negative 1 over t and plus 3, isn't it? Are you okay with this?
Yeah.
So after t go to infinite, where is the particles? So we're gonna take a limit value, okay? Limit t go to infinite. So 6 minus particle p first. Particle p. 6 minus 4 over e to the what? Infinite. How much this one? E to the infinite is infinite. 4 over infinite is 0. So this one equals to 6. Finally, particle p, where is it? 6 over here. Alright? And what? Infinite time of t, particle arrives at this point. So this origin, they have a 6 away, right? 6 unit away. That's the particle p over there. The particle q, limit, when t go to infinite, this is particle position, particle q. Negative 1 over t and plus 3. But this will go to infinite, this whole thing is 0, right? So the limit value is 3. At this time, q is 3 over here. Okay? So which particle eventually be parted? Particle P. It's okay? You can answer right, particle P. Okay? You can leave a shorter work over here, okay? Because what? 6 is greater than 3, okay? Particle P is farther, right? From the origin. You can answer this way, okay? But this one we tried all the questions because it looks easy, okay? But you think it's hard, just try your first 2 questions, A and B, okay? Are you okay with this?
Yeah.
Okay, I'm gonna stop this one, okay?